Welcome to this video on application security by design. After watching this video, you will be able to describe the software development lifecycle, SDLC, and its importance, recognize the significance of application security, identify key secure coding practices for enhancing application security. The software development lifecycle, SDLC, is a sequence of stages outlining the software development process from the beginning to the end. The SDLC starts with planning, identifying and analyzing requirements, then goes through design, programming, testing, deployment, and maintenance. While not everyone follows a formal SDLC model, it's common in large-scale developments, at least to some extent. As digital threats and sophisticated cyberattacks continue to increase frequently, there is a growing need to enhance application security. It involves incorporating a series of secure practices and processes into every phase of the software creation process. The main objective of application security is to enhance the overall security of applications by detecting and resolving security problems and preventing them from occurring in the first place. Application security is not just a one-time task. It spans the entire lifecycle of an application, from the initial design stage to the final maintenance stage. We refer to this process as security by design. Here are some key coding practices that are crucial for application security: input validation, error handling, secure logging, avoid leaving hard-coded credentials, access control, encryption, and software secure testing. Let's explore each one in detail. Input validation is a programming technique that ensures data entered into an application is correct, safe, and in the expected format before processing. It acts as a first line of defense and safeguards the system from potentially harmful or erroneous input that could lead to security issues or crashes. Without input validation, a system is vulnerable to various attacks, such as SQL injection. In an SQL injection attack, an adversary could enter SQL code into an input field that expects a username or password. If the input is inserted directly into a database query without validation, the malicious SQL code can execute, potentially giving the attacker unauthorized access to sensitive data. The next is error handling. It involves responding to and managing errors that arise during application operation. It's like having a plan B when things don't go as expected in a software program. Instead of allowing a program to crash or expose vulnerabilities when encountering a problem, error handling enables the software to deal with the issue in a predetermined way. For example, it could display a user-friendly error message or take corrective action without shutting down. The third key practice is secure logging. It involves recording events to track user and system activities, making it easier to understand how the software operates and identify any unusual or unauthorized activities. Ensuring these logs remain inaccessible to unauthorized parties is crucial. By keeping logs secure, only those who genuinely need to know have access to the sensitive information, helping to protect the application and its data from potential threats. Without secure logging, an insider with bad intentions could manipulate financial transaction records or alter logs without a trace. The next one is to avoid leaving hard-coded credentials. Hard-coded credentials are sensitive pieces of information, such as usernames, passwords, or API keys, that are sometimes embedded directly into the source code of an application. This practice is like hiding a spare key under your doormat. It's convenient for those who know where to look, but also a significant security risk. If attackers discover these credentials, they could gain unauthorized access to systems, databases, or services at the level of the embedded permissions. To reduce this risk, developers should keep sensitive information in safe places, like secret management systems or encrypted files. The fifth key practice is access control. It ensures that only authorized users can access specific data or functionalities. It is important for maintaining application security and preserving sensitive information's confidentiality, integrity, and availability. By implementing strong access control measures, a software application can prevent unauthorized users from getting into places they shouldn't be, like private databases or admin settings, keeping the application's environment secure and operations running smoothly. Encryption is another important coding practice. It involves converting information or data into a code. To implement encryption effectively, developers should use cryptography libraries that are widely recognized, have undergone thorough security reviews, and are actively maintained by experts. Applications should encrypt sensitive data like personal details, financial information, or confidential communication during storage and transit. It prevents unauthorized access during storage or transfer between systems, networks, or devices. The last one is software security testing. It is a critical process designed to assess and ensure the overall security of a software application. It involves a series of evaluations to uncover vulnerabilities, flaws, or weaknesses that malicious actors could exploit. Security testing aims to identify potential security risks before deploying the software publicly, ensuring it can defend against attacks and protect sensitive data. In this video, you learn that the software development lifecycle is a structured sequence of stages outlining the software development process from the beginning to the end. Application security involves incorporating a series of secure practices and processes into every phase of the software creation process. The key secure coding practices for enhancing application security include input validation, error handling, secure logging, avoid leaving hard-coded credentials, access control, encryption, and software secure testing.